So today we will cover from model 2, that is the thread. So these are the outline of today's topic. So first we will learn what is thread. Next we will learn thread versus process. Next we will learn types of thread. Next we will learn the difference between user level thread and the kernel level thread. Next we will learn thread models. Next we will learn the thread lifecycle. So these are the learning objective and the learning outcomes. So what are the learning objective? To understand the services provided by operating system and the design of an operating system. Number 2 objective is students should understand the data structures and algorithm used to implement operating system. And what are the outcomes? After completing this topic, a student will be able to analyze the kernel and the user mode in an operating system, evaluate and report appropriate design choices when solving a real-world problem. So now we will start our today topic, that is thread. So what is thread? So assume in our internet, assume there is a website, assume like that facebook.com or instagram.com or any other popular website which are available nowadays. There are thousands people are using the website. That means if you execute 1,000 people in a sequential manner, that means to complete the sequential task it will take much more time. But if we compute or if you execute in parallel fashion, or we will allocate each user for a particular moment or time, then it will take less time. So assume for Facebook there are thousands of people are using or thousands of people are want to log in to their account. So at that moment, what will do the facebook.com server? It will do that it will assign a thread. Thread means a small process to each user, and each thread will have execution time within a particular limited time. By this manner, if one thread is executing in a single moment, that means next thread will come just after the first thread. Next third thread, fourth thread. By this manner, execution will be completed. So if the server will take the approach as sequential execution, so it will take thousands of hours or thousands of minutes to only completion of login. But if CPU or if the server will allocate thread to a particular user, that means at parallel there can be many people are executing the same task, or many people can log in into the system. So what is thread? So a thread is a flow of execution through the process code with its own program counter that keep tracks of which instruction to execute next, system registers which hold its current working variables, and a stack which contains the execution history. A thread shares with its peer threads few information like code segment, data segment, and open files. When one thread alters a code segment memory item, all other threads see that. A thread is also called lightweighted process. Thread provides a way to improve application performance through parallelism. I have already mentioned that. Thread represents a software approach to improving performance of operating system by reducing the overhead is equivalent to a classical process. So that means the sequential process, whatever the time it will take to execute a particular task, if you consider the thread model, it will take the less time. Similarly, just go to the number 2 points. Threads shared with its peer threads. That means if there are 3 threads, thread 1, thread 2, thread 3, that means there are 3 separate processes are there. That means they will share some memory location, or they will share some data which can be visible to each other. Okay, and thread is also called lightweighted process. Lightweighted process means it is a small process or small class. Okay, So these are the very basic definition of thread. So each thread belongs to exactly to one process. For a particular process there should be at least one thread, and no thread can exist outside the process. So whatever the thread is there outside process, it cannot be possible. Each thread represents a separate flow of control. Threads have been successfully used in implementing network server and web server. They also provide a suitable foundation for parallel execution of application to share on multiprocessor. So these are the very basic definition or the introductory part of the thread. Now this is thread. So in that case, just see the first quadrant. In the first quadrant there is only one process and one thread. So within a one process there is a just the black line, curly black line. This is the one thread process, but that means it is a small piece of code of information. Next one is the next quadrant. Just right, if you come to the clockwise manner, so there is one process and multiple thread. In the next case there is, in the third quadrant, multiple process and multiple threads are there, and in the fourth quadrant multiple processes are there, but each multiple process will hold only one thread. So the following figure shows the working of a single threaded and multi-threaded model. So in the single threaded model, just see the left hand side. There are register, there are counter, there are the stack, there is a data files, there is a files part, and there is a code segment also. Okay, so this is the single thread of code, the dotted line. And in the next part there are three threads, first thread, second thread, and third thread, and there is a code part. The code part is shared between all the first, second, third thread. Okay, so here just see that first thread, second thread, and the third thread. And this is the coding part, the code part, which is shared between all these three threads. And if some data is changes over here, all other threads can visible. Okay, now there is a single thread. A single thread will have its own register, own counter, own stack. Similarly, there are three threads. Three threads have their separate register, separate counter, separate stack. Again separate register, separate counter, separate stack. Again separate register, separate counter, separate stack. Okay, so these are the single process with three threads. This is one example. Okay, so just remember this, each thread will have their own register, own counter, own stack, and own code segment also. But whenever it will be in multi-threading model means there are more than one thread are involved. In that case also, for all this case, first thread, second thread, third thread, they will have their separate register, counter, stack also. But there are some code of information which are shared between all these threads. Okay, just remember that. So what are the advantages of using thread? So thread minimizes the context switching time. So what is context switching time? Context switching time means the time to jump between process 1 to process 2, or the jump between thread 1 to the time required to jump between thread 1 to thread 2. I have already told you that thread is a light-weighted process. That means it is a small-weighted process, a very smart process. Okay, so that means it will minimize the context switching time. It's quite natural. Okay, next is use of thread provides concurrency with a process. So thread model will provide you concurrency. Concurrency means at the same time some data can be altered, or both the thread will want to access the same data, etc. Next is the efficient communication. Next is it is more economical to create and context switch thread. So it is very cheaper, or overhead is very less as compared to the any conventional process handling model. Okay, next one is thread allows utilization of multiprocessor architecture to a greater scale and efficiency. So these are the important point you have to remember. First one, the context switching time is less. Next one, it provides concurrency. It creates efficient communication. Next was, it is very economical. That means it is less overhead. Next, thread will allow utilization of multiprocessor. That means CPU utilization is much more higher than any other process. Okay. So these are the basic difference between thread and the process. So from the process we have learned that a process is a heavy weighted process or resource intensive process. But in case of thread is a light weighted, taking lesser resources than a process. Okay. Next one, process switching needs interaction with operating system. But in case of thread switching does not need to interact with operating system. The third point, in multiple processing environments, each process executes the same code but has its own memory and file resources. But all threads can share same set of open files, child processes. This thing you have to remember. Number 4, if one process is blocked, then no other process can execute until the first process is unblocked. While one thread is blocked and waiting, a second thread in the same task can run. Number 5, multiple processes without using threads use more resources, but in case of thread, resource using count is very less. Number 6, in multiple process, each process operates independently of each other, but in thread model, read, write or change any other thread's data can be possible. So these are the point you have to remember. Process is a heavy weighted process, thread is a light weighted process, process required much more RAM, thread requires less RAM. In multiple processing environment, process is very slow, but in case of thread, if you apply thread model, it is faster. Similarly, CPU utilization is high in thread, but in case of process, CPU utilization is not too much high. In multiple processes, each process operates independently, but in case of thread, read, write and change of data, this also can be possible. Okay. So usually there are two types of thread. One thread is called the user level thread that manages mainly manages those threads, and the kernel level thread, operating system managed thread acting on kernel and operating system. Okay. So what is user level thread? Just see the diagram. In the diagram there are two spaces. One space is called kernel space and the above space is called the user space. In the kernel space there are process table, there is kernel, but in case of user space there is a process. Within this process there are 3 threads. There is another process, there is also another process. In the second process there are 4 threads, and here there is 3 threads, and this round shaped figure is the process, and the table is called the thread table, and this is the runtime system for the process. So in this case, the thread management kernel is not aware of the existing of the threads. The thread library contains code for creating and destroying threads, for passing messages and data between threads, for scheduling thread execution, for saving and restoring thread context. The application starts with single threads. Okay, so this is the diagram, remember, for user level thread. So in this diagram there are process table, there is thread table. Thread table mainly manages information for the related thread. Process table mainly manages what are the processes are available in our system. Okay, process table work under the control of kernel space, and thread table works in the control of user space. So what are the advantages of user level thread? Thread switching does not require kernel mode privileges. User level thread can run on any operating system. Scheduling can be application specific in the user level thread. User level threads are first to create and manage. What are the disadvantages? In a typical operating system, most system calls are blocking, but multi-threaded application cannot take advantage of multiprocessing. So these are the points you have to remember. Next, kernel level threads. So in kernel level, thread management is done by the kernel. There is no thread management code in the application area. Kernel threads are supported directly by the operating system. Any application can be programmed to be multi-threaded. All of the threads within an application are supported within a single process. The kernel maintains context information for the process as a whole and for individual threads within the process. Scheduling by kernel is done on a thread basis. The kernel performs thread criteria scheduling management in kernel space. Kernel threads are generally slower to create and manage than the user level thread. What are the advantages? Kernel can usually simultaneously schedule multiple threads from the same processes on multiple processes. If one thread in a process is blocked, the kernel can schedule another thread of the same process. Kernel routines themselves can be multi-threaded. What are the disadvantages? Kernel threads are generally slower to create and manage than the user level thread. Transfer of control from one thread to another thread within the same process require mode switch to kernel. So what are the basic difference between user level thread and the kernel level thread? It is a summary of the previous topic. So user level thread are faster, kernel level thread are slower. Implementation is by a thread library at the user level. Operating system supports creation of kernel thread. User level thread is generic and can run on any operating system. Kernel level thread is specific to the operating system. Multi-threaded application cannot take advantage of multiprocessing. Kernel routines themselves can be multi-threading. So what is multi-threading model? Multi-threading model means whenever there is more than one thread are involved. Okay, so some operating system provide a combined user level and kernel level thread facility. Solaris is a good example of this combined approach. In a combined system, multiple threads within the same application can run in parallel or multiple processors, and a blocking system called need not block the entire process. So multi-threading models are three types: many-to-many relationship, many-to-one relationship, one-to-one relationship. So this is the many-to-many relationship. In the kernel space, there are m number of kernel level thread, and in the user level thread there are n number of user level thread. So maybe n number of user or m number of kernel level thread, they both are dependent to each other. That means controls are automatically managed by all the kernel level space thread. So the many-to-many model multiplexes any number of user threads onto an equal or smaller number of kernel threads. Assume there is a in kernel level space, this is the kernel level thread. Okay, so this kernel level thread can control all the n number of user level thread. Next, number two is also controlling the maximum of n number of or less than the n number of thread. Similarly, the last kernel level thread. This thread also controls the either equal to n number of thread or less than n number of thread. Okay, so the following diagram shows the many-to-many threading model where 6 user level thread are multiplexing with 6 kernel level thread. Okay, in this model developers can create as many as user thread as necessary, and corresponding kernel level thread can run in parallel on a multiprocessor machine. This model provides the best accuracy on concurrency, and when thread performs a blocking system call, the kernel can schedule another thread for execution. So many to one. In this diagram, just see there is only one kernel level thread and there is n number of user level thread. So in many to one model maps many user level threads to one kernel level thread. Thread management is done in user space by the thread library. Then thread makes a blocking system call. The entire process will be blocked. Only one thread can access the kernel at a time, so multiple threads are unable to run parallel on multiprocessor. If the user level threads libraries are implemented in the operating system in such a way that the system does not support them, then kernel thread use many to one relationship model. That means whenever kernel thread K will be managed thread 1, then thread 2, 3, 4, the n number of thread has to wait or it will go to a blocking state. These are the funda. Next one is the one-to-one thread. That means for thread 1, thread 2, thread n, there are n number of kernel thread are available. So there is one-to-one relationship of user level thread to the kernel level thread. This model provides more concurrency than the many-to-many model. It also allows another thread to run when a thread makes a blocking system call. It supports multiple threads to execute in parallel on microprocessors. And there are some disadvantages of the system. Disadvantage of this model is that creating user thread requires corresponding kernel thread. OS2, Windows NT, Windows 2000 use one-to-one relationship model. Okay. Next is the thread life cycle. So in the thread life cycle, just like process life cycle, just see over here. In the process life cycle, we have seen that the first step of a process is new. Then from the new state, it will go to the waiting or the ready state. From the ready to it will go to the running. From the running, it will go to the waiting. And after completion of task, it will go to the terminated or the dead state. Similarly, for a multi-threading model or any thread model, first a thread will execute or start it from the starting state. From the starting state, processor will assign a particular thread to the running state. From the running state, there can be 4 different scenarios. One is either the execution is completed, so it will terminate it and process will end. This is one scenario. Next is number 1 scenario, that is the wait, sleep and join. A process can be go to a particular time limit. That means assume I will tell you thread 1 will sleep for 20 milliseconds or thread 2 will wait for 10 milliseconds or 10 nanoseconds. That means after completion of 10 nanosecond or after completion of 20 millisecond, again the thread will join to the started state, then again it will go to the running state. This is one scenario. Another one is called the suspended. That means if there are some problem will occur during the execution, this thread can be suspended. From the suspended, another system call will be called, that is called the resume. Resume will again submit this thread to the started state. This is number 2 scenario. Next one, if there are some problem, the thread or execution can be aborted. This is the 3rd scenario. Next one is the block. What is block? That means for a particular moment, assume there are some input output related operation or any IO operation. That means for that particular moment that execution will be blocked. So after blocking over here, again the process or thread will join to the started here. So this thing you have to remember. First the thread will be submitted to the system, then it will go to the started, then it will go to the running. From the running it will go to the wait sleep join, this kind of state 1. It will then go to the suspended state, then it will go to the abort state, then it will go to the block state. This thing you have to remember, and regarding the each step what is actually going on you have to explain. So regarding this thing, for your exam, what are the thing are important? Regarding important thing is you have to prepare the thread life cycle. Next you have to prepare the different multi-threading models, that is the many to many, many to one, one to one relationship, and remember the diagram. These are the very important thing. Next one is the what are the difference between user level thread and the kernel level thread, and another one is the what are the difference between process and thread. So these are the very much important. So you have to prepare or you have to remember everything regarding this topic. Next one, these are the textbook. For the theoretical part you can go to the first book, that is the Galvin operating system books. Next, for the multi-threading part you can also choose any Java related books or any Java related content from the website and the online courseware whatever we are providing. These are the important questions for your exam. For any semester exam or internal exam, explain different thread models with diagram. This kind of question will carry 5 or 6 marks. Next is explain thread life cycle with suitable diagram. It will also carry 5 or 6 marks. Next one is the write down the short notes on thread versus process. So whenever you will write thread versus process or user level thread versus kernel level thread, one thing you have to remember, always write down in the tabular form. If you don't write in tabular form, your marks will be reduced. And the next one is the what do you mean by the multi-threading. This question, multi-threading means whenever there are more than one threader involved. This scenario is called the multi-threading. 5. Explain the benefits of thread. So what are the benefits of thread? That means it is a lightweighted process. This is one benefit. Communication is better. It is faster. Overhead is very less as compared to the any other traditional method. So this thing you have to remember, and also it will increase the concurrency and parallelism. This thing you have to remember for the benefits of threads. And next one is the why thread is called lightweighted process. Lightweighted process means a thread is nothing but a small piece of code for your as a program. So whenever you will learn Java, you will see that you can create thread some existing system classes or file. So from this existing library you can create thread 1, thread 2, thread 3. That means very small Java classes or C++ classes you can create as a thread, and by the help of operating system you can execute this thread as a concurrent manner. So these are the important thing you have to remember. Okay, so if you have any query or if you have any problem related to your class or the understanding of this topic, just give me an email. You can reach me to my LinkedIn account, my Facebook page or my YouTube channel. So whenever you can, I am available always. So these are the things you have to remember from this topic. So thank you.